Okay, so what we're going to do is solve. Oops. You can tell what color I was using last time. And I'm going to be honest with you that it may look like you have a lot of homework, but several of the problems have already been factored for you. So your job is to set each factor that contains a variable equal to 0 and solve. Okay? So the first several that I have for you are that way. So somebody has taken their polynomial, put it in descending degree order, factored it, and it looks like all they had in the first one was a GCMF. So you got 5x times the quantity x minus 4 equals 0. So we've already factored it. That launches us into setting each factor that contains a variable equal to 0. So 5x has a variable, so we're going to set them equal to 0. X minus 4 has a variable, so we're going to set it equal to 0. Because I don't know what value of x is the 0 value, so I have to solve for all of the possible values. Okay? So on the first one, I'm going to divide both sides by 5. On the other one, opposite operation says I'm adding 4. Notice that we're using skills from Chapter 3 on this. Chapter 3 was how do we solve equations? How do we get a variable alone? So we get x equals 0. It is perfectly acceptable to divide 0 by anything. Okay, that direction is good. And then we have x equals 4. Now, we don't have any fractions in our problem, so we would not get something that's contradictory. Okay, now, how do we test that this works? Well, if you put 0 into the first equation, up there, we get 5 times 0 is 0, 0 times anything is 0, done. If we put in x equals 4 into the equation, we get 5 times 4 is 20, and then in the parentheses, 4 take away 4 is 0, so I have 20 times 0 is 0. So they both work. So my answers gets written this way. Braces, 0, comma, 4. Close braces. It does not matter the order of the values in your solution. As long as you have both solutions, that's all that matters. Okay? Second one, they've also factored for you. So this was a trinomial, it looks like. It could have been a trinomial or a polynomial where you had a factor by grouping. With the trinomial, looking at my 3n and 5n, you had to play the game. You had big numbers. It was kind of a pain. So this is kind of nice that they did this one for us. So again, I'm going to take any factor that contains a variable, set it equal to 0, and solve. So we go back to our skills, excuse me, from Chapter 3, and we do opposite operations, starting with adding or subtracting the opposite of that. So this one we're going to add 2 to both sides. The second one we're going to subtract 8 from both sides. So that gives me 3n equals 2 and 5n equals negative 8. Then we're going to do the next. Opposite of multiplying by 3 is dividing by 3. Opposite of multiplying by 5 is dividing by 5. So that gives me n equals 2/3, n equals negative 8/5. So again, I can test my answers and plug in 2/3. Now if I plug in 2/3 there, I get 3 times 2/3 is 2. 2 take away 2 is 0. So now that I have a factor that's 0, the whole left side has to equal 0, because 0 times anything is 0. When I take this guy, the smartest place to plug him in is there. 5 times negative 8/5 is negative 8. Negative 8 plus 8 is 0. 0 times anything gives me 0. So both answers are good, and my solutions are 2/3 and negative 8/5. Now, please remember, when we're writing fractions, the best way to do them is vertically, not slanted. High school really hates it when you guys do that. All right, so enough of the baby stuff. I know you guys like the baby stuff. Let's make you work a little harder. So now they haven't factored it already for us, but they did do one step for us. They put it in descending degree order, polynomial on the left equals 0 on the right. So that's good. So now what I have to do is factor. And the first question we ask, always, is there a GCMF? And is there one?
Yes.
Yeah, there happens to be an x. So we're going to factor out the x. And x squared divided by x is x, and 3x divided by x is 3. So the rules say, the directions say, take every factor that contains a variable and set it equal to 0. Does x contain a variable? Yes. So x equals 0. Well, that was an easy solution. And then x plus 3, we're going to set it equal to 0 and solve. So we've already solved on the x. The second one, I'm going to do opposite operations. I'm going to subtract 3 from both sides, and I get x equals negative 3. Actually, I'm going to change him to black. Sorry. And again, where I should be testing is back to the original problems. So 0 plus 3 times 0, which is 0, does 0 plus 0 equal 0? Yeah. Okay. So if we try negative 3, we get negative 3 squared is 9. 3 times negative 3 is negative 9. 9 plus negative 9 is 0, equals 0. So they both work.
Yes.
So I write it in solution set notation, 0, negative 3. Probably the most common mistake, kids forget about the x equals 0. And they just lop it off and just say the answer is negative 3. You got to remember, any factor that contains a variable is a solution. Or you can set equal to 0 and solve. All right, now we're going to get even more mean. 7n squared minus 3 equals 4n. All right, so what's wrong with this one?
17.
Yeah, it's not equal to 0. So that's job 1, is we have to get it to equal 0. So let's go ahead and subtract 4n from both sides. And the thing to remember is we got to put it in descending degree order. So I have 7n squared minus 4n minus 3 equals 0. Fabulous. So now I look, is there a GCMF?
Nope.
No. We thought that would help, but no. So next, we have 3 terms. Is it a trinomial square? You guys should not even hesitate.
No.
7 is not a perfect square, so guess what? We're stuck with playing the game. Not that that's really stuck, that's actually really helpful. So what are factors? The product number are going to be 7 times negative 3 is negative 21, and then the sum number is negative 4. So what are 2 numbers that multiply to give me negative 21 but add to give me negative 4? Rachel?
Negative 7 and positive 3.
Negative 7, positive 3. Everybody agree?
Yeah.
Okay. So now we're going to have to create that polynomial, and I'm going to create the 2 middle terms, negative 7n plus 3n. And then we have minus 3 equals 0. And I'm going to tell you, this is my pet peeve, is that kids ignore the equals 0 and then somehow just come up with the answer down the line. I want you to have pure mathematics. I want there to be justifiable. I start with equation. I have an equation throughout the problem. So what you're seeing here is what my expectation is. So then we're going to factor by grouping. These two have a 7n. These two have a positive 3. So we get 7n times the quantity n minus 1 plus 3 times the quantity n minus 1 equals 0. So we end up having the common binomial of n minus 1, and the 7n and the plus 3 form their own binomial. Now we're finally to what number 2 looked like. It took us this long to get to there, but that's just the reality of it. Not all your problems are going to be like this, okay? So now we're going to go ahead and take each one that contains a variable, and set it equal to 0 and solve. So n minus 1 equals 0, 7n plus 3 equals 0. So again, we're going to do opposite operations. On this one, we're going to add 1 to both sides. This one, subtracting 3 from both sides, remembering to always start with adding or subtracting those opposites. So we get n equals 1. And we get 7n equals negative 3. So this one requires 1 extra round. I'm going to divide both sides by 7. and that gives me n equals -3/7. And again, this is where it gets a little funny when you check your answer. If I plugged in, and this is why checking is always better on paper than in your head. 1 squared is 1, 7 times 1 is 7. 7 take away 3 is 4. 4 times 1 is 4. Does 4 equal 4? Yes. Then comes the ugly. This is the one I don't like doing. -3/7 squared. Well, that's going to give me 9/49. That times 7, 9/7. Minus 3, now I got to go into turning it into a fraction. Oh my gosh. And you start getting discombobulated. In your head with fractions, bad idea. You want to check your work with fractions, you're going to want to physically do it. So you would be doing 7 times -3/7 squared. And by the way, why do we check our work?
To see if it's right.
Yeah. If you want to guarantee that you got something right, well, closer to a guarantee, then you need to check. So this gives me 9/7, and I'm going to change him into 21/7. And -21 and 9, let's see, that's going to give me a -12/7. And sure enough, it works. So there's verification that you have it right. So for your answer, in your solution set notation, you have 1 and -3/7. I can already see by Taylor's face, she's like, I'm not going to be doing that on every problem I'm working on. Okay, so you have to be a little bit thoughtful about what you're going to do. All right, let's still look at some more, the ones that are going to create the most amount of work for you, because we love to make you do work. So number 5, we've got 2x squared equals -128 plus 32x. And just like the last problem, this one's ugly in that it doesn't equal 0. So that's our first job, is we're going to have to solve this problem so that it equals 0. The other thing that you need to keep in mind, this is really important. If you are going to do difference of squares, if you're going to do trinomial squares, if you're going to do the game, if you're going to factor by grouping, you want your first term with the highest exponent to be positive. All the strategies we've learned are based on your first quadratic coefficient to be positive. When it comes to learning quadratic formula down the line, you have a little bit more flexibility. Right now you have none. So you want to take everything to the side where the x squared is, because he's positive. So that means you're going to add 128 to both sides, and you're going to subtract 32x from both sides. So now your equation is 2x squared minus 32x plus 128. Remember, you always write it in descending degree order. So the first question in our flow chart that we did yesterday was, is there a GCMF? And the answer is, oh yeah, we finally do have one. We have a 2. So we're going to factor out the 2. And that's going to leave behind an x squared minus a 16x plus 64. So the question is, I have a trinomial. Is it a trinomial square? And I always check for that because remember we talked about yesterday, it is far faster to factor a trinomial square than it is to play the game. So I'm just going to quickly check it. Let's see, I can take the square root of him. I can take the square root of him. When I multiply those and double them, yes! I end up getting the middle term. So this tells me it is a trinomial square. So I'm going to grab him, and the sign of the middle. So here's where you're at. 2 times the quantity x minus 8 squared equals 0. Now, our direction said, set any factor that contains a variable equal to 0. Why would we not do this?
Because 2 isn't a variable.
2 isn't a variable, and can 2 equal 0?
No.
That's why we don't set coefficients equal to 0. Oh. Okay, that's why we don't set coefficients equal to 0, because we don't get a value for it. Now, what's x minus 8 quantity squared actually look like? Alexis. x minus 8 times x minus 8. Are there two different values in there? It's the same thing twice, right? Blake's going, no, 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 no. So guess what? In this particular case, when I have a trinomial square, I have only one factor to set equal to 0 and solve for. So, do opposite operations. I add 8 to both sides. And I get x equals 8. And again, we could go out and do this. Now, here's the funny thing. Do I need to use solution set notation?
Yes.
Yeah.
Okay. What's the reason for using solution set notation?
To make it look fancy.
No, it's not to make it look fancy or pretty.
It's if there's two possible answers.
It's if there's more than one answer. If there is only one answer, bam.
Oh.
Now, is it illegal for you to write the answer in solution set notation without the variable? No, you can do it that way if you want. So you could write it also as this. But here's the deal. If you left it as x equals 8, you'd be done. Here you had to take one more step to get to the answer. Okay? All right. Let's do, I'm going to skip. We've got 5 more minutes. So get back over here. This is a really important one. So I've got the quantity y minus 5 times the quantity y plus 2 equals negative 12. So they factored it for us, but does it equal 0?
Nope. No.
So here's the problem here. You can't just add 12 to both sides and say it equals 0, now what? Because you've got two factors and then you have something being added to it. You can't deal with it in that form. So when you're faced with this particular problem, your only option is to go back to Chapter 5 and to double distribute, FOIL, matrix, so that you have no more parentheses. So I'm going to double distribute. Y times y is y squared. Y times 2 is 2y. Negative 5 times y is negative 5y. Negative 5 times 2 is negative 10. Equals negative 12. Then I'm going to go ahead and do opposite operations, and I'm going to add 12 to both sides, and then I'm going to combine up like terms. Taylor, you writing this down? So I've got like terms here, 2y and negative 3, or negative 5y is negative 3y, and negative 10 plus positive 12 is positive 2. Do I have a trinomial square? Because I can tell there's no GCMF. 2 doesn't have a variable and y squared doesn't have a coefficient. So then that means we're going to play the game on this one. What are factors of positive 2 that add to give me negative 3? This is pretty easy because there's not too many factors of 2. Negative 1 and negative 2. So this becomes y squared minus y minus 2y plus 2. Do you guys remember what I talked about yesterday? If you're factoring and your quadratic coefficient is 1, you've played the game. What should be true about the factors you get? You guys remember? See if you remember when we do this. Oops, I'm going to do a different color. So these have a y in common. These have a negative 2 in common, so I have to be cautious with that. So we've got y times the quantity y minus 1 minus 2 times, let's see, negative 2y times divided by negative 2 is a positive y. 2 divided by negative 2 is a negative 1. We end up getting what we want for common binomial, and we form the second binomial. Do you guys notice? Remember what we talked about yesterday? What do you guys see? Voila. That's only because my quadratic coefficient was 1. That would have saved me time if I remembered that. So now I take y minus 1 equals 0, y minus 2 equals 0, do opposite operations, add 1, add 2, and I get y equals 1, y equals 2. So my solution set contains both 1 and 2. Okay. Okay, 2 more examples. Number 7, we've got 25a equals a cubed. Now when we get everything on one side and 0 on the other, we need to make sure that the factor with the largest exponent is positive. So I'm actually going to subtract 25a from both sides. Now that gives me 0 equals a cubed minus 25x. And we're going to use that property, symmetric property, to rearrange this equation to make it a cubed minus 25x equals 0. Next, we look for a GCMF. And, oops, it's supposed to be an A. Sorry, I don't know why I put X's in there. Let me go correct that. So we do have a GCMF, which would be A. So we're going to factor out the A, and that would leave behind a squared minus 25 equals 0. So then we look at what's left behind, and it's a binomial, so what we're looking for is the difference of squares, and that's precisely what we have. So remember, when we cut the apple up yesterday, every time I made a cut, I ended up with 2 new pieces. So that one piece, the a squared minus 25, now becomes the new pieces of a's in front, 5's in back, one sum, one difference. So now I'm supposed to take and set each factor equal to 0, and that's each factor that contains a variable. So I have 3 factors that contain variables. The first one's already solved, and in the next, I'm going to subtract 5 from both sides. I'm going to add 5 to both sides, and I get a equals negative 5 and a equals positive 5. So this is one of those occasions where we have 3 good answers, and we have 2 options when, we have an answer that is the same number but opposite signs. We can use that plus minus. So we could also write this as the solution set contains 0 and positive or negative 5. So those are 2 ways to write the same answer. Okay, and then we have one more. Last one, number 8. We have 9x cubed minus 18x squared equals x minus 2. So job 1, get everything on one side, 0 on the other. So we're going to take the minus x and positive 2, get everything on the left. So our equation is 9x squared, or excuse me, 9x cubed minus 18x squared minus x plus 2 equals 0. And then we're going to factor by grouping. So the first 2 have a 9x squared in common, and the second 2, have to be careful, has a negative 1 in common. So when I factor out the 9x squared, I'm left with an x minus 2, and when I factor out the negative 1, I have a positive x minus a 2. Well, let me go back and change that. And all of that equals 0. So we get the x minus 2, and then we have the 9x squared minus 1 equals 0. So I have to look at each binomial that has a minus to see if it's a difference of squares. First one, x isn't a perfect square, but on the next one, I do have the difference of squares. Square root of 9x squared is 3x. square root of 1 is 1. So I still have the x minus 2, but now I get two binomials to replace, the 9x squared minus 1, and it's going to be 3x plus 1 and 3x minus 1. So I'm going to take each factor that contains a variable, set it equal to 0, and solve. So I'm going to add 2 to both sides, subtract 1, add 1 in all of those. So I get x equals 2, so there's one solution. 3x equals negative 1. 3x equals positive 1. Divide by 3 on both of these. And that gives me x equals negative 1/3. X equals positive 1/3. So my solution set contains 2 and positive and negative 1/3. And you can write them out separately if you would like.